All right, my name is Stephen Emery, and I'm going to tell you about my project, Ring the Bell, which is an arcade machine that I designed and built, and then connected to the internet. So I'm going to briefly give you a introduction to the project, and then I'm going to explain the software that I wrote for this project to make it work. And yeah, that's those 4 bottom points there. And security, of course, is super important in this day and age. Right, so Ring the Bell is actually an electrical puzzle. So I've got this bank of relays here, so power comes in here, and the player has to figure out the proper sequence to turn on these relays to complete the circuit and ring this bell. There is a Arduino Uno under this board here in the middle that's running the whole game. So it puts power to these relays and can sense when the bell's ringing via this relay here. So there are 3 switches down here which are connected to the Arduino. So if you get a high score, you can put in your initials and it will update the displays there and save that to its EEPROM memory. So I wanted to be able to put this in a bar or an arcade or something and be able to see how many plays it's getting, how often it's being played, that sort of thing. And I also wanted to be able to do firmware updates to the Arduino, because there are 12 screws in this Lexan lid. So every time I had to make a change, I'd have to pull out all 12 of those, run a USB cable back there. And so I decided that the most expedient route to making this work would be to add a Raspberry Pi, which you can see just there. And the other reason why I wanted to do that is because this is what the underside of that board looks like. So there is an Arduino buried under there, and then above it is one of the Arduino proto shields. So all the components and cables that go to different things in the box all go to that board. And because there are platforms that I could have used to do this, particle I/O and so on, but I didn't want to have to remake everything, because I was very, very close to being done with this project, and I just wanted a couple more features. And so you can see that the Pi here is connected. It's getting its power from this device here. I believe, Jerry, this question came up at one of the Pi meetups: is how do you power your Pi?
Yep.
Okay, so this is an unpaid advertisement for Adafruit's UBEC, stands for Universal Battery Emulator Circuit. It's a DC to DC step-down converter. So highly efficient. It has a wide range of input, I believe, but I was really only interested in going from 12 volts to 5 volts. And so that's will give you 3 amps out, which is more than enough to power all of the 5 volt circuitry I've got in this box. So that's the Arduino itself, all 4 of those displays on the other side, and the Pi here. Previously, I had been using just a LM7805 with a heatsink, but even so, it was drawing a 1/2 amp, and that was putting out enough. Yeah, it was too hot to touch. This, however, you'll notice has no heatsink and remains cool to the touch. And I'm pulling almost 1/2 amp from all this circuitry. So yeah, so then here's, I guess at this point now, a summary of what I just said. So it's got an Uno that does all the game logic, Raspberry Pi B+, not 3B+, just B+, that does the IoT stuff. And then I had to use a real-time clock, because I discovered that whenever it would boot up and create a log file, the time would be wrong, because it takes a certain amount of time to pull the time off the network, and I couldn't find any straight answers on when that time becomes valid. So I just said, okay, fine, real-time clock will always know what time it is. So the DS3130 or 3231 is same as the DS1307, which all the libraries on the Pi are named after, but has the same interface. So it's a drop-in replacement. It's temperature compensated, so it's the crystal is temperature compensated, so it's more accurate than that device. The downside, it's larger, but it still fits comfortably inside my case here. You can see it's this little chip here. It actually mounts onto the GPIO header. And I hot glued it on for good measure, so it doesn't vibe out. So yeah, just a little Wi-Fi adapter there to do Wi-Fi, and the UBEC, like I said before. So that's the hardware. So now I'm going to show you what the website looks like. So if any of you have done hosted your website via DreamHost, then this page will look familiar to you. So this is very simply just the root directory of my personal website, which I used because I had it, so why not? So all the website files are here. So you'll see these two files up here, and what these are actually serial numbers of Raspberry Pis. So whenever one of my Pis connects to this website, they will put their files in the appropriate folder. Check the appropriate folder for firmware updates, and if the folder doesn't exist, they will create one. So in that way, I can have an SD card from a Pi, clone it, and just put it on a bunch of Pis, and they will all not compete with each other to overwrite log files. So if we go into one of that, so that second one there is the one that's actually in my machine. So there's two files here. The first one there is heartbeat.txt. So every time my Pi is trying to look for a firmware update on this site, it will update this heartbeat file so that I can see that it's connected. And that file just simply has a timestamp in it because I don't like converting from whatever time zone this is. And then the log file there is the log file that's generated every time an event happens that the Pi logs. So whenever the Pi boots up, that's an event. Whenever a game happens, that's an event. Whenever the firmware is updated, that's an event. Whenever somebody goes into the secret service menu, that's an event. And also it'll log errors. The only error I've got right now is if the Arduino reboots itself, then because there's no way for that to happen, so that's obviously wrong. So that'll get logged in there too. So here's an example of what this file looks like, or rather, what this file looks like after it's been exported to Excel. Because it's simply a text file, a comma-separated variable. So each of these rows here is actually just a line in the file separated by commas. And that is a format that's understood by Excel, so it goes in very nicely. So you see here I have, so it says these are all events. We had a startup event and then a menu event. So this is where I went in and I cleared out all the high scores. And then we have some people playing. So number of games played increases, number of games won increases, the coins that got put in increased, and then we have the firmware version there.
Question on the web file.
Yeah.
Are you like keeping a separate copy of it on the Pi, or are you like just adding?
Yes. Yeah. So every time an event happens, the file is updated locally on the Pi, and then so if it can't get a connection, it'll still have all of the data there.
Nice.
The slight downside to that is it updates the whole file every time. Well, not that big. I can get 1,000 lines and it's still under 40 kilobytes. So, I mean, it'll be a problem eventually, but you can just or that.
Yeah, you could.
Or just move it to a different folder and just create a new file if it gets too big.
Or start sending RESTful commands to your backend server.
So this is also the first IoT project I've ever done.
Yeah.
Also my first Pi project and my first Python project.
Well, we'll talk about IoT Hub. We'll get you on board. No worries.
Okay. Okay, so now I'm going to go into how the software that runs on the Pi, which I wrote entirely in Python, works to do these features that I've been showing you. So I have a main script that cron runs at startup, and then it just runs continuously. So all it does is communicate with the Arduino, update the log file, try to send the log file, and then it's also looking to see if a new version of the firmware has been downloaded. So yeah, so I developed a, okay, so I guess back to this page real quick. So I am connected between the Pi and the Arduino using the Arduino's USB port, which is of course serial over USB, and this goes into one of the Pi's USB ports. So I had to develop a communication protocol between the two. Because if there's one thing you need to take away from this presentation today, is that whenever you open a serial port on the Pi, it will reset the Arduino.
There's a fix for that.
Yeah.
STTY no hub CL or
Yeah, no
something.
hub or whatever.
I have to Google it, but it took me a long time to find that out, and I've suffered with it for a long
You
time.
can fix
Okay.
it.
But
Yeah, or you can have some workarounds like what I've done here. The Arduino, of course, boots almost instantly, and then the Pi takes flipping forever. So about 50 seconds, I've noticed. Maybe the new Pis are faster, but B plus boots in about 50 seconds. So in this application, it would be disastrous if the Arduino were to reset while somebody was playing, because they would lose all their credits, they would lose their progress. So the Arduino actually comes up with a message on one of its displays that just says booting. And so it will wait in that state until it gets this message from the Pi. So it'll just send the byte capital R. Also, I have adopted the standard that any messages sent by the Arduino will be in lowercase letters, and the Pi will send uppercase letters. So if I was to be sniffing on the serial, I would be able to see who's saying what.
that's good, yeah.
Yeah, so anyway, so when the Arduino boots, it sends lowercase r to the Pi, and then so if the Pi is still booting, it won't respond, and then once the Pi comes up, opens the serial port, and reboots the Arduino will again come to that point, send R, but now the Pi is ready. Pi sends uppercase R, and then the Arduino goes into its regular operating mode. And the Pi goes into its operating mode, which is it'll be waiting for the Arduino to send over game records. And so I've parsed them or formatted them like so. So you see I've again got lowercase letters for the different fields. So I for initials, and then there's my initials, for example. Time in milliseconds, number of games played, number of games won, and the number of coins, and the version number ends with the carriage return. So then this all gets formatted and then appended to that log file, which is then uploaded to the server. And like I said, if it doesn't have a subfolder with the right serial number, it'll create that. Then there's what I'm going to talk about next is how I am getting new firmware down onto the Pi to be loaded onto the Arduino. But once it is on the Pi, then this is the script that has to tell the Arduino to stop playing games and take this update. Because again, if you were to do a firmware update when somebody's playing, they wouldn't be very happy about that. So this time the Pi will send over capital U for update, and then once the Arduino is in a state that it is, as the players have used all of their credits and nobody's playing any more games, that will send over U, and then go into basically a while one loop until the hex file gets loaded. With AVRDO, by the way. Because you can, actually the entire Arduino environment can be run on a Pi. But I'm just, like you, using AVRDO just to get that hex file over there. Okay, so and then I've got this other script that is constantly checking for updates, and it's checking for updates and not the other way around, so I can get out through firewalls. Because if they were trying to connect in and there was a firewall, it would throw away that message. But since it's originating from inside the firewall, the replies come in. So it just checks once per minute, and then it creates this file and puts it up on the server. Again, so I can tell that it's connected, because if nobody's playing, I wouldn't know otherwise if I had a connection or just nobody was playing at the moment. So then it will download the hex file and delete the hex file that's there from the server. So I have two ways to know that the firmware update was successful. The first is the file I put in will be missing, and then the second is the log file will show me that there was a firmware event. And then the third would be when somebody plays a game, it then coughs up the version number, and I would see that would be a different version than what was the previous entry in the log file. And it won't download the hex code if there's already hex code waiting to be put on the Arduino. And then this is important. It will stop the main script from reading this file until it's completely downloaded. And there may be internal mechanisms in Linux to do that, but what I did is I simply just wrote a file to that folder, and if that file is present, the main script will not read this file until that file is deleted. So just a simple lock file. And what's next? Oh yes, so then the other issue is how do you connect this thing to a Wi-Fi network, especially when you haven't been on before. Again, because there's 12 screws on that box, and I don't want to reach in with a HDMI connector and a keyboard every time I want to set it up somewhere. So what I did is I wrote a script which will append the SSID and password to the end of the WPA supplicant file, which is where Linux keeps all of its all the network names that it connects to. So how I do this is I have my phone configured as a hotspot, and I had to take out the spaces and apostrophes to make it work. But which I understand there's workarounds for, but I haven't gotten any of them to work yet. Right, so connect to the machine using a iPhone, and then I have a SSH client on my phone, so I can SSH in and get to a command line. So I just run this script with the SSID and password as arguments. They get appended. I reboot, and I take the phone out of hotspot mode so it doesn't connect to the phone again, and then that works theoretically. I say theoretically because it's worked sometimes, but other times I've had issues with this. And now let's talk about how I have secured this system. So the first thing to secure is people trying to log into the Pi. So the first thing is I created an entirely new user account and password, and I deleted the default one. So now anybody trying to log into that Pi user will find nothing. And then I'm running uncomplicated firewall to seal up all of the ports except for the SSH port. And I have this program called fail to ban, which will block IP addresses temporarily after they fail to log in a certain number of times. So that slows down the Chinese.
And the Brazilians.
And the Brazilians?
I used to see a lot of those in logs.
They just really like ringing bells.
I guess so.
Don't look for a bell anywhere.
Yeah, really.
Very stereotypical. Everybody knows that about it.
Anyway, so then as far as then securing the server, because I don't want my website to get hijacked, I'm using SFTP, and so something I just want to say about FTP for those of you who don't know, the username and password are actually transmitted unencrypted. So if you're using FTP and somebody sees that packet, they will know your username and password, and they can log into that machine. For that reason, and for the reason that I'm using the native SFTP program to send SFTP data, I am using RSA keys. So RSA keys are encrypted files, or files for encryption, I guess. Anyway, so they're really easy to generate. You put one on your machine, you put one on the machine that you'd like to talk to, and then they can just connect and start talking.
It's a really cheap and easy thing. If you just move your SSH off of 22 onto some other port, like 9953, you'll get a lot fewer hits, because a lot of scripts are so stupid, all they do is check 22, and they move on.
Okay.
It's a really cheap and easy thing to do.
Okay, a very good point. I don't know if I can do that because I've got DreamHost on that side, so I think they control like the port numbers. I don't know if you can get in through other ports.
But they're not logging into your Pi.
correct?
You're logging into that.
Right, and so I mean I do have an account with DreamHost, but I don't know that that's one of the options I have to change the ports of what I can log into. But yeah, security by obfuscation.
Yeah, it's not good, but it's so cheap and easy, and the number of hits you get on your firewall will go way down.
Sure, yeah.
That could be like the name of your, like, the marketing message for it. It's not good, but it's cheap and easy.
It's easy.
We got this part of it right.
Okay.
Yeah, so I guess one further thing I want to say about SFTP is I couldn't find a library to do SFTP in Python for the Raspberry Pi. There's one, it's called Pachinko or Ponico or something like that. And they haven't ported that over to the Pi. So I had to write my own function to use the command line SFTP. And so the way that works is very simply I just use Python to write a batch file, and then I feed that into the command line SFTP function. And since I'm doing that every minute now, I have created a temporary file system to put these batch files so I'm not always writing to the SD card and wearing it out or risking corruption if somebody were to turn the machine off while it was writing one of these files. And which brings me to the Q&A.
How are you managing coins?
What's that?
Coins.
I don't know if I have a picture of it here.
If that's secretive for obvious reasons.
No. So the coin mechanism I'm using is the one you can get from SparkFun. It's really cool. You can encode up to 6 different types of coins into it. You program it yourself by putting the coins in, so you get a good sample size of coins and run them through until it learns to recognize the coin.
Wow.
So it's even cooler because you also set how much a credit is versus how much a coin is. So for me, it's 1-to-1. 1 quarter is 1 credit, but I could have programmed in dimes and nickels, and somebody could have had to put in 2 dimes and a nickel, or five nickels, and
Will it do any order?
in any order, yeah.
How's it verifying that? Not physically, obviously.
Just size?
How does it verify what kind of a coin it is?
Yeah.
I believe it's how fast the coin rotates as it rolls into the machine.
Yeah.
I think it'd be funny if you made the nickel like 10 credits, and like anyone who's dumb enough to put a nickel into your machine gets a reward.
Yeah, you could do it, but yeah, as far as verifying it, it's amazing. It will reject Canadian quarters.
Wow.
It will reject.
Politely.
What fake things will it accept is my question.
Things that roll fast.
None I've found yet, but yeah,
Okay.
I tried all the dimes and quarters and pennies and.
How big is this thing?
Electrical block.
Because you can see, I don't know if you can really tell from this picture how big my machine is, but that's like 8 inches deep.
Wait, where is it?
So
is that?
you can't see it.
Okay.
Sorry, it's like over here.
I never even noticed that with your machine, but.
Well, it was on free play, so.
Oh, okay.
So what inspired you to do this?
Well, we were talking earlier. You can get a chip with 300K of RAM for $3.50. So you don't think, what can you do with relays, which are still perfectly functional. They just can't do what you can do with 300K of RAM. But that was why I built this, was to demonstrate something interesting you can do with relay logic.
And I will add that I think relays are very cool.
Yeah,
Always
yeah, they make a very gratifying thunk whenever they energize, which you don't get from Arduino.
Not what it was.
Yeah, so this project was about physical computing. And that's a little different than the way they talk about Arduino and stuff. But yeah, because you can do computing with you don't need computers to do computing.
Do you ever find you are running into race conditions with your? relays?
No.
No relay races.
No.
I'm
Yeah.
so sorry.
Yeah.
Do you know about the IAAPA conference, which is the people who make coin-op video games?
Okay.
It's in Orlando this week at the convention
Oh, wow.
center.
Oh, wow. Okay.
So, like, people who make pinball machines and redemption
wow.
games
Okay.
and roller coasters
Wow.
and all that stuff.
IIAP?
IAAPA or something like that.
Okay.
It's at the convention center.
Okay, whatever. Whichever one's at the convention center now.
Just
Got
walk
it.
over there.
Okay.
That's awesome.
It's a very fun machine too, by the way, even though I couldn't solve it.
Very.
So you said did you say you have an electrical engineering background? What?
It's electrical engineering background, but it's slowly morphing towards software.
Yeah, I see that. That's pretty awesome.
So I've never done a Pi project. You said this is your first one.
Never
Yeah.
understood.
If somebody else knows, could you have done this with
Right,
just
yeah.
like Bash scripts and Linux? Would that?
Probably.
Okay.
There's a lot you can do with Bash, but
Yep.
I haven't delved into that yet. And I'm not sure I finished talking about the coin slot. Actually, I can probably. Here, I'll just set up my hotspot here so I can get on the internet. Maybe.
So while you do that, if it doesn't distract you too much, what kind of future plans do you have for this thing?
So like I said, my next goal is to put this in a bar and see what kind of interest it gets there, because I have, because I've taken it to, this is now, so this was at Maker Faire last weekend. I was also there in 2015. I was at Free Play Florida 2015. I've been to a couple other conventions as well, and it gets a lot of interest, but I wonder if people would actually pay for that experience. So next phase is to put it in a bar or something, and yeah, see what people think of it. I mean, I don't see myself, launching a company based on this anytime soon.
That appears to be hand-built, yes.
Yeah, it's hand built, but I mean, I've learned a lot. I could go to the next revision, which is
Adding a credit card.
that too.
Bitcoin?
Well, that I
Bitcoin.
really want to do the
It's a
credit
Bitcoin
cards
scepter.
so I can actually find out how many
Example
unique players
for
I have.
Ah.
Because if I take their credit card data, I know who's at the machine.
Well,
Yeah, then you
I
gotta
think you're going to
report
violate
this.
some rules depending on what credit
Well,
card you use.
I might be able to hash it or something so that I don't know what the number is, and I have a safe number to put in my database. But as long as it's the same, then I can say, oh, okay, this person played 3 times.
Yeah.
Because that's the cycle. That's the data I wish I could collect with this machine.
Mhm.
Is if somebody plays once, will they play twice?
Just do some heuristics on like how fast they click the buttons.
That's actually what I can do right now. Well, not how fast they click the button, but how close the games are together.
Oh, there you
Yeah,
go.
that's probably some
Yeah,
way.
yeah. Because the only switches that I have access to from the Arduino is the first 3, and they are actually electrically isolated from the circuit while the game's in operation, because those. Okay, so I'm saving I/O by using those 3 up-down rockers and putting them into the analog input,
Yeah.
and then using a voltage divider, so that neutral is at 2.5 volts, and then up is 5 and down is 0. The gotcha there is apparently that's really sensitive to the EMF that's kicked
Oh, yeah,
off by
yeah,
these.
of course. It's a high impedance input.
Well, they're all high impedance inputs, but that one is actually causing the processor to reset. Just those 3, and I suppose I don't blame it because the switches are all.
Well, the back EMF off those coils has got to be kind of high too.
Yeah, so that's actually next on my list is try to snub those a bit.
So does each one of those coils have digital input on the Arduino?
Each one of those what's?
Each one of those relays has a digital input.
No, I don't know what they're doing.
You don't.
Yeah, that's what I was getting to, is only the first 3 switches. So each of these switches are 2-pole switches, which means they have 2 switching elements in one package. So they all have ones that are connected to the puzzle, but on the first 3, use that second set of contacts for the data input. And also going through the menu that I had to design in. So yeah, I know there's a lot you can cram into an Arduino.
Oh, yeah. That thing is just great.
It's beautiful.
It's
You have to
beautiful.
see
Oh yeah, well,
Thank
well
you, yes.
constructed,
It's very cool.
very thoughtful.
How heavy is it?
It's luggable. So if you have 2 people, you can move it easily. I have one of those furniture carts, so I just tip it on its side, unscrew the legs off the bottom, and roll away. Yeah, my hotspot's not working here anymore. It was working earlier. But yeah, so SparkFun has a device that's about this big. I mean, it has a profile like that, so it is panel mount, so it's bolted to the front of my machine. And then, and I laser cut a box for the coins to go into. But yeah, so you can program up to 6 denominations, and then you can play with how much the coins are worth versus how much a credit is, and it will not send that data over to the Arduino, which it has by serial and by just doing a discrete line that goes low or high. I think you can configure that too. So that the second thing I mentioned, the discrete pulse, is which also you can set that. You can determine how long you want that width to be, which I actually had to step up from its minimum because of how long all of the Arduino functions take. Yeah, because I have half of mine to rewrite this code using Atmel Studio, so I have interrupt access, so I don't have to constantly pull that coin port. And I could just have an interrupt.
Well, you can do interrupts with Arduino.
Arduino, yeah.
Yeah.
You can do that now?
Oh, yeah.
Attach interrupt.
Attach an interrupt to whatever pins are interrupt capable on the board.
Oh.
You call your function
Yeah.
whenever the interrupt goes off. Works pretty well.
Okay, that sounds pretty good. Yeah. Oh, and then not only will it so wait for the number of coins to be put in to match the credit level, but it will remember the remainder. So if it's 25 cents and you put in 3 dimes, it'll remember that there's 5 cents credit left in there. And I was like, no, that is way too complicated to explain to people. So
Better just
it's
take
quarters.
quarters.
You're taking quarters. You're gonna put quarters in. That's it.
Anything else you put in is a donation.
Actually, it's really good at rejecting them, so it'll just spit them right back out.
Oh wow.
Yeah, that's great.
How much is that little box?
$500.
It's
A lot of quarters. You have to buy the quarters.
It's worth more than the quarters of me.
I
working yet.
I could think of so many uses.
I did some work in vending, and those coin things are so complicated, and they don't you can't put denominations in there. It's just like this size coin fits the lever, you get a credit.
Let's see. Here we go. Oh, it's a different company though. Here we go. It is $44.95.
Hmm.
A lot of quarters.
That's
Well,
that's
you-
nothing.
they're gonna keep 5-year sales, so.
Yeah, and
Quarters. Just quarters.
yeah, so you can see, and then I've got this cable that runs from the Arduino over to there, so that it runs on 12 volts. I believe the logic line out is 5 volts. Oh, actually, and then this is important. It also has an inhibit line, so you can tell it to stop taking more quarters.
Oh.
Wow. If it's full.
Well, if it's full, or if I'm doing my firmware update, or if or that sort of thing. It's like,
That's
no, you're
Wow.
not putting in quarters when I can't check for them.
I love the attention to detail in this thing.
Oh, yeah.
It's so yeah, it didn't happen overnight, and yeah, it just there's so many things like that just pop up. You don't realize when you start a project like this how many of those things there will be.
Yeah.
Oh, yeah.
But yeah, so that's a takeaway is, yeah, projects like this don't happen overnight, and just fix the problems as you find them.
Yeah. Great.
Really good.
All right, thanks, Stephen.
Thank you.
Oh, I'm in the same road.
Drop off.
I-